Hi everyone, welcome to my YouTube channel Techie Code Buddy. I hope you are doing extremely well and your placement preparation is also going well. Well guys, first of all, if you are new to this channel or haven't subscribed this channel till now, then do consider subscribing this channel as this really motivates me to make more such content for you and for your placement preparation. Also guys, don't forget to turn on the notification bell so that you will never miss any update from my side. Also, you can join our Telegram community. The link for the same is given in the description box. This is open for discussion and all the study material is provided in this group. So make sure to join. All that stuff is free, so you don't need to pay even a single rupee. Okay, so let's start with the video now. So in this video, what we are going to cover, we will be seeing a coding question that is recently asked in Accenture exam. So as your Accenture exam is going on, okay, so you have to practice more and more so that you will crack the exam in the very first attempt. Let's start with the question now. So what is question saying? Just let me take the pen. Yeah. Suppose there are n bulbs that are initially switched off. We first turn on all the bulbs. Then we turn off every second bulb. Then on the third round, we toggle every third bulb. What is toggle means here? It means if the bulb is off, then you have to make it on. And if the bulb is on, then you have to turn it off. All right. Now, similarly, for the ith round, we toggle every ith bulb. Okay. Now, for the nth round, we only toggle the last bulb. So we have to find out how many bulbs are on after n rounds. Okay. So basically, this problem is available on LeetCode also, and this is a medium level problem. Actually, the thing is, the answer is pretty simple. The code is pretty simple, but the thing is, you have to visualize the pattern. You have to analyze the things that how the things are working in this particular problem. Okay, you have to use your mind on a very good level. But don't worry, I will make the solution super easy for you to visualize, to analyze. Okay, so just keep watching this video and we will be solving everything. We will be making logic. We will be code in VS Code. Okay, so don't worry. So let's start with the question now. So here is a sample test kit first. So suppose there are three bulbs and according to the question, all the bulbs were initially switched off. So this time the bulbs are switched off. Now what you have to do, the actual question starts from here only. We first turn on all the bulbs. So at the round one, or we can say at the iteration one, first of all, we turn on all the bulbs. So here we have turn on all the bulbs. Now at the second round, you have to turn off every second bulb. Okay, so every second bulb, that means you will first turn off second bulb, then fourth bulb, then sixth bulb, and so and so. But as this sample test case only contains three bulbs, so you will turn off only second bulb. So here we have turn off our second bulb. All right, and the remaining bulb will be same as it is. If they are on, so they will be remain on. If they are off, so they will be remain off. Okay, now at the third round, what you have to do, you have to toggle the state of the every third bulb. Okay, so here as only three bulbs, so we will toggle the state of third bulb. Okay, so we will toggle, so we will be playing with only third bulb. All right, we will not play with first or second bulb. We will left as it is on these state only. So first bulb was on, so it is on. Okay, second bulb was on, so it is on. So we have to just play with third bulb. Okay, and we have to toggle the state of the third bulb this time. So it was on, so now we are toggling it and we will make it as off. So this is how. Now at the last, we have to tell that how many bulbs are on at the last iteration or at the last round. So at the nth round, we have only one bulb that is on. So this is our answer. Okay, this is our answer. So let's take sample test case 2. Suppose there is only one bulb and at the very first time, initially it is off. Now, as there is only one bulb, so there will be only one iteration, and in the very first iteration, what we are doing, we are turning all the bulbs, turning on all the bulbs. So at the very first iteration, this bulb will be on, right? So this bulb is on. As there are only one iteration, so the last stage only this. So we have on, how many bulbs we have on here? Only one bulb, so one will be the answer over here. Okay, so by seeing this pattern, you don't analyze anything. So let's visualize it on more test cases. Okay, so first of all, what we will take, suppose there are 6 bulbs. All right, so what we will do, I am writing here bulb number 1, bulb number 2, bulb number 3, bulb number 4, bulb number 5, and bulb number 6. Right? Now, these are rounds. Sorry, just a minute. These are rounds from here. Okay. So this is the very first round. This is second round. This is third round. This is fourth round. This is fifth round. This is sixth round. Why 6? Because n count is 6. Total number of bulbs is 6. So the very first thing was, initially all the bulbs were off. So these bulbs this time are off. Okay. Now at the first iteration, what you have to do, you have to make all the bulbs turn on. So what we will do, we will turn on all the bulbs. So this time these all will be on. Just analyze the pattern. Okay, what I'm doing, just see it. Don't use your mind, just see it. Now, at the second time, you have to turn off every second bulb. That is the multiple of 2. All right. That means you have to turn off second bulb, fourth bulb, and the sixth bulb here. So what you will do? You will turn off all the second position wala bulb. So second, so it will off. Okay. It will be off. Now fourth bulb off, and now sixth bulb. All right. Now all the bulbs will remain same. So this is on. This is on. This is on. All right. Now at the third iteration, what you have to do, you have to toggle the state of every third bulb. That means every multiple of 3. Okay. Each multiple of 3, you have to toggle the state of that bulb. Now here in this sample test kit, what are the multiples of 3? The multiples of 3 is 3 and 6. All right. So what we will do, we will be toggling the situation or state of third and sixth bulb. Okay, so this is on, so we will make it off, and if it is off, so we will make it on. All right, we have done with this, and remaining bulb will be as it is, off, and on. Now every fourth round means na, every ith round you have to toggle the state of every ith bulb. That means here we have to toggle the state of every fourth bulb. So first of all, we will toggle the state of every fourth bulb. That means first, fourth, that and toggle state will be on. Okay, and the next should be eighth. But as here we have only 6 bulbs, so we will not jump over 8. Okay, and all the bulbs, all the remaining bulbs will be same: on, off, on, on. All right. Now, at the fifth iteration, we have to toggle the state of fifth bulb. Okay, so here we will toggle the state, so it will be off, and all the remaining will be as it is: off, on. And at the last, at the nth iteration, you will be toggling the state of nth bulb. That means 6. So we will make it off. Okay, and remaining will be as it is: off, on, off. So how many bulbs are there which are on? Okay, so bulb number 1 and bulb number 4. Okay, so what are the bulbs? Bulb 1 and bulb 4. That means 1, 4. All right. Now just run this logic, or just run the problem statement on one more example. Okay, so let's take the example of n equals to suppose 9. Okay, 9. Okay, n equals to 9. So here are rounds, and here are bulbs. Bulb number 1, bulb number 2, bulb number 3. So now initially they are all off, and at the very first time we have to make them on. So we will be doing the same. First, just a minute. First we will make it on, 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 on. All right. Okay, at the very first iteration. Now at the second iteration, what we are doing, just let me take the second iteration a little bit upper side, otherwise we will not having the space to solve the question properly. Okay, so at the second iteration, you have to turn off every second bulb. That means 2, 4, 6, 8. Okay, now you have to turn off all the second bulbs. So here off, fourth bulb will be off, sixth bulb will be off, and eighth bulb will be off, and further 10th bulb will be off. But here we have only 9 bulbs, so we will not go further. So remaining bulb will be on. All right. Now, at the third iteration, what we have to do, we have to toggle the state of each third bulb, or we can say we have to toggle the state of every third bulb. That means the multiple of 3. So 3, 6, and 9 will be toggled. So this is on, so it will be off, and sixth bulb is off, so it will be on, and ninth bulb is on, so it will be off. All right, and all the bulbs will remain as it is in their state. Off, on, sorry, this should on, and this should be off. So this is on. Now, at fourth iteration, every fourth bulb will be toggled. That means fourth and eighth bulb will be toggled in their state. So this is off, so this will become on, and this is off, so this will become also on, and other will be as it is: on, off, off, on, 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 off. All right. Now at the fifth iteration, every fifth bulb will be toggled in this state, and further all the remaining will be same. So here first should be 5 and another should be 10, so there is only 9 bulbs, so we will not move further. So only fifth bulb will change in their state and remaining will be as it is. So let's toggle this situation. So this should be off and all the bulbs remain same: off, off, on, 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 and off. So at sixth time the sixth bulb will be toggled. Okay, so it is off and similar are on. Now seventh round, so every seventh bulb will be toggled. So this will be off and remaining will be as it is. At the eighth iteration, the eighth bulb will be toggled. That means this will be off and all the remain as it is. And at the ninth iteration, the ninth will toggled. Okay, so it will on and remaining will off, 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 on, off, off, on. So how many bulbs are on at the ninth round, or we can say at the last round? So first bulb, then fourth bulb, then ninth bulb. Only these bulbs are on at the last round. First bulb, fourth bulb, and ninth bulb. Okay, so let's dry run this problem statement on a little large test case. Okay, so here we have already had a table and there are 16 bulbs. All right, now there will be 16 rounds as well. At the very initial stage all the bulbs were off, but at round 1 what we are doing, we will be turning on all the bulbs. So this time all the bulbs are on. Okay, so on, 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 on. You can skip this writing part, okay, but I have to complete the solution. Okay, so at the very first round you have make all the bulbs turned on. Now at the second iteration you have to off each second bulb. Okay, means second bulb, fourth bulb, sixth bulb, eighth bulb, 10th bulb, 12th bulb, 14th bulb, and 16th bulb. So let's make them off, 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 off. Now at the third iteration you have to toggle the state of each third bulb, right? So first of all let's see here: on, 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 on. And at the third time, you have to toggle the state of every third bulb. That means it is on, so it makes off. It is on the sixth bulb. It is off, so it will on the ninth bulb. It will be off the 12th bulb. It will be on the 15th bulb. Each multiple of 3. Okay. So it will be off. And all the bulbs will remain as it is. On, off, off, on, off, off, on, off, and off. Okay. Now at the fourth iteration, each fourth bulb will be toggled in this state. So each fourth, that means fourth, eighth, 12th, and 16th. All right. Fourth, so it will be on. Eighth, so it will be on. 12th, it will be off. 16th, it will be on. All right. Now all the bulbs will remain as it is. On, off, off. Okay. Now at the fifth iteration, you have to toggle the state of fifth bulb, each fifth bulb. That means 5, 10, and 15. All right. So 5 will be toggled, so it will be off. 10th will be toggled, so it will be on. 15th will be toggled, so it will be on. All right. And remaining bulb as it is. On, off, off, on, 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 off, on, off, on, off, on. Now, at the sixth iteration, you have to toggle the each sixth bulb. Okay, so sixth bulb and 12th bulb will be toggled here. So sixth bulb is on, so it will become off, and 12th will become also on. It is toggled down. So all the bulbs will remain as it is. On, off, off. Seventh. So every seventh bulb will be toggled in their state. Seventh and 14th bulb will be toggled. So seventh bulb is this. So it will be toggled. So it will become off, and the 14th bulb will be on. Right? Now all the bulbs will remain as it is. On, off, off, on, on. All right. Now every eighth bulb will be toggled in their states, and then eighth after 16th bulb. So first of all, let's toggle the eighth bulb and then toggle the 16th bulb. So eighth bulb is this. So this will be toggled in their state and it will become off, and 16th bulb is this. So it will become off. All right. Same as it is for all the bulbs. Off, off, on, off. All right. Now each ninth bulb will be toggled and all the remaining will same. So 9th and 18th, but there we are only having 16 bulbs, so only 9th 12 will be toggled in their state. So this is off this time, so this will become on, and all the remaining bulb will be same as it is. So on, off, off, on, off, off, and off. All right. Now every 10th bulb will be toggled. So 10th bulb. Okay. So 10th bulb will be toggled. So it will now off. As it was on, so it will become off after toggling. So each bulb will remain same as it is. On, off, off, on, on, and off. All right. Now 11th bulb will be toggled and all the bulbs will remain same. So 11th bulb, that means this bulb. So it will become off after toggling and each bulb will remain as it is. So on, off, off, on, on. All right. Now every 12th bulb will be toggled in their state and remain as it is. Okay, so on, off. So 12th bulb, that means this bulb only. So it will become off and the remaining will as it is. So off, on, off, off. Now every 13th bulb will be toggled. So every 13th, that means this will be off and all the remaining will as it is. On, off, off, on, off, 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 on, off, 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 on, and off. Now every 14th bulb will be toggled. So this is the column number 14. So every 14th bulb will be toggled. So this 14 bulb will be toggled and it will make off and all the remaining will same. Off, on, off. Okay, now every 15th bulb, that means this bulb, so it will become off. Okay, and remain will as it is, off, on. Now every 16th bulb, that means the last bulb will become on, and all the remain bulb will as it is, off, 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 and off. Okay, okay, so yeah, finally we have done with our table. Now let's find out how many bulbs are on. So the very first bulb is on, the fourth bulb is on, the ninth bulb is on, and the last one, the 16th bulb is on. So the answer is 1, 4, 9, and 16. Okay, and in the previous test cases also, the answer was 1, 4. Okay, so the total will be 2. Now here, the answer was 149. So the total on bulb will be 3. Now the answer is 1496. So can you find out the pattern? Can you find out the pattern? So those bulbs are on at the last stage who are the perfect square. Means 1 is perfect square, so it is on. 4 is perfect square, so it is also on. 9 is perfect square, so it is also on. 16 is perfect square, so it is also on. So the total count at the last test case, that means n equals to 16, the total number of bulbs that are on at the last time, 4, right? For 9, how many perfect square till 9? So 1 and 4 and 9. So 3. So the answer will be 3. So the answer is pretty simple. Then we have to just find out the square, perfect square. How many perfect square till 9? And we have to return the answer. Okay, I hope you guessed the logic. I hope you have visualized the pattern. I hope you got the idea. I tried my best to make the solution understandable to you. So let's code it. Okay, so let's code it. Just so we are here in the VS Code. So first of all, this line, just let me take the pen and we will be solving. Yeah, this line is for test cases, that how many test cases are there in our code. Okay, then while loop is for running the test cases. Then this is the count of bulb. Okay, from here we are taking input, and answer will be, we will call a function that will return the turned on bulbs at the last stage. Okay, so this function will return only the square root of n. Okay, the square root of n. That means if n equals to 9, so the square root is 3. And for the count of ninth bulb, there will only 1, 4, and ninth bulb will turn on. Right, so the answer is 3. And if we give 4, so 1 and 4, so answer will be 2 on. Turned on bulb at the very last stage. Okay, so let's run this code for 3 input output. Okay, so let's run this code for 3 input output. So 3 test cases. So first of all, we have give the 3 bulb, then we have give the 9 bulb, and then we will have give the 6 bulb. So let's run this code. For the bulb count equals to 3, the last bulb that is on is 1 only. And for the ninth bulb, okay, for 9 bulb, there is 3 bulb that will be on at the last stage, and for 15 bulb, there will be 4 bulb. Now you might be thinking that 9 square root is, 3 square root is 1.327 something. So why it is 1 here? So as we are storing our answer is in integer form, so it will only consider the integer part of it. So that's why the answer is 1. Okay. So if we take the input as n equals to 5, so how many bulbs should be there? So there should be 1 and fourth bulb, that means 2. So if we give output, so if we give input n equals to 5, so what should be the answer? The answer should be 2, right? But what is the square root of 5? That is 2 point something. But we will consider only the integer part, so that's why the answer will be 2. So let's try the simple input and let's find out the output of it. Okay, so just wait for a second. I'm making here 4 test cases, and the last input will be 5. All right, then we will run this code. So the last answer is also 2. Okay, so there will be only 2 bulbs that will turn on at the very last stage, and those bulbs will be 1th bulb and 4th bulb. Only the perfect square bulb will be on at the last stage, and all the remain will off. Okay, so yeah, that's all for today from my side. I hope all the things are clear to you. I hope you get the logic, and I will be able to make the solution understandable to you. So we will meet in the next video. Till then, bye bye and take care.